Hey everyone, welcome to question 8 from the chapter 6 review. The question is asking us to solve the following trigonometric equation. So we want to know when tangent of x, so what mystery angle, do we need to put into tangent in order to get an output or a ratio that equates to 1 for all solutions. So this idea of for all solutions is important because if you think about it in terms of the circle, we're asking ourselves, where are we going to hit these points along the circle as we continue to go around and revolve an infinite number of times? So that means that our solution is going to kind of take on kind of an equation look to it. So what we want to note here is, well, let's go ahead and focus on the tangent function itself. So I want to know when, in general, when what I get from a tangent. So if you recall from chapter 5, we had said that tangent comes about when we do the ratio of y over x. So in other words, if you pick a coordinate point along the circumference of the circle, we're going to do a ratio of the y coordinate value over the x coordinate value. So we want to ask ourselves, where is this possible? Where am I going to get a positive 1 as a y value? So one of those situations might be when you look at a, say, 45-degree angle. Because at that point, this would give us a root 2 over 2, sorry, that's kind of small, for our x value, and a root 2 over 2 for our y value. So in other words, if we were to do that ratio of the y value all over the x value, we get a positive 1. You could also argue, well, yes, I agree with this, but then we can also note that if I go over here and basically do, let me think here, 225 degrees, we would land at the point of negative root 2 over 2, negative root 2 over 2, if we looked at that coordinate point. And again, negative root 2 over 2 divided by negative root 2 over 2. The negatives would become positive since a negative divided by a negative is equivalent to a positive, and it also gives us a 1. So if we think about this, though, there's a couple ways that we can look at this, and we want to try to streamline this as best we can. So what I want to note here is, well, essentially, my x values that I'm going to work with, they're going to be a version of pi fourths plus 180 degrees, or pi, and then times k, and most of us probably already have it kind of talking out in the back of our mind where k is an integer. Okay, so the reasoning behind this solution is, well, if I start at 45 degrees and then I add another 180 degrees, I'm back to a terminal side where I would get a tangent value equivalent to 1. And then again, if I were to repeat this and then say, all right, if I add another 180 degrees, oh look, I'm back to another terminal side that would give me a tangent value whose output is 1. And then we can continue to go around again, and here's 180 degrees. Oh look, I'm hitting a value where the tangent would be equivalent to 1. Then another 180. Then another 180. Then another 180. And then another 180, and so on. And I can keep doing this, and every time I add 180 degrees, I'm hitting that terminal side whose tangent would give me a value of 1 as an output. I hope this explanation has been helpful, and if you do need anything else from me, please either message me via WAMAP or send me an email. You can also feel free to leave a comment underneath this video on YouTube. All right, thank you very much.